Everybody, now let's give the final example for Fourier series, and then let's move on to Fourier transform, which is chapter 4. Now let me give an example. The example asks us to find the Fourier series coefficients of a square wave. The Fourier series of a square wave can be found through applying the formula that was given. So let me first write the square wave expression, which is xt takes a value of 1 when t is t's absolute value is smaller than t1, and then it is 0 when t is bigger than t1 and then smaller than capital T, which is the period over 2. So we already know the formulas, and we are required to find the Fourier series coefficients. So because of symmetry, we know that the symmetry is something like this. The square wave goes like this, and then it goes on until t over 2, and then we again have the same thing. And because of the symmetry, we are going to take t between minus t over 2 until t over 2. And these ones refer to the period capital T. Okay, so AK is equal to, and let me first give the actual formula: 1 over t integrated over t x t times e to the power of minus j n omega small t dt. And then since we take it until t1, we are going to first consider here, and here the value is 1, so we can write this as 1 over t. From minus t1 to t1, we have 1 times e to the power of minus j k w omega, t dt, right? And for k equals 0, we will have a 0 equals 1 over t from like this. We will have xt 1 times e to the, since k is 0, we will have e to 0 dt, and it will give us 1 over t times t1 minus t1, which eventually we will have 2t1 over t. Alright? The coefficient of a0 is 2t1 over t. However, if k is not equal to 0, then what we will have? We will have ak equals, instead of here, if we consider that k is not 0, we will have an expression like this. And from t1, from minus t1 to t1, and this one will equal to this expression. Okay, so by taking this one out and multiplying the denominator and numerator with 2, we will basically have and with minus 2, I'm sorry, minus 2, let me say it like this. We will have this expression over 2j And then since we already know that this part is equal to sin k omega t1, we can write it as a k, the coefficient, is equal to sin k omega t1 over k omega t, and this basically equals to sin, instead of we can write omega 0, we can write 2 pi over t, and this one equals to sine k omega t1 over k pi. So this is the Fourier series coefficients if k is not equal to 0, and we have concluded this question.